Hi, this is Candace, Mazique Hinton, and I'm coming to you with my week 2 information, my video for my week 2. Um, Let me get here so I can share my screen. Okay, so here we go. In our first one, number 1, here we are with the Earth surroundings. And this also tells us about how we move and the speed that things move in while the Earth is still orbiting and the surroundings around it. Here we see that Earth's rotation really doesn't have much. You have the Milky Way and you have Earth's orbit. I was really curious about what was before the initial picture. As you see, we have a lot of pictures of things in different sizes. So when we were shown them, instead of going forward, I went backwards. Just a moment. Okay. I think I'm back. Let me make sure. And I'm back to doing what I was supposed to be doing. Okay. So, as I was talking about, here we go. Here you see I have up quark and down quark. Now, the up quark and the down quark, we're about 10 to the negative 18th power. And this is the size of these items. And it was very interesting to me because I'd never heard of a quark and didn't know anything about it. So that's what caught my attention. And a quark is a particle which forms matter. I didn't know that. Okay, but in reference to our speed, if we were standing still on the equator, which I still didn't quite understand the concept even after I looked at the video, but we would still be moving at 444 meters per second because the Earth and all its counterparts would be moving even though we're standing still. Our third question, everything has a measurement, and there are several different types of measurements available, from the smallest thing that's unseen to the biggest. And that kind of tells you about this picture as well. There were various pictures there. And this is, like I said, just the one that caught my eye. You just have to be accurate in the choice you make to measure or weigh the items that you're trying to measure. And in measuring, negative numbers mean that it's smaller or less than 1, and positive, larger numbers means that it's more or greater than 1. The E in the mathematical equation is just another way to write a scientific notation on a calculator or a computer. For number 2, we had to look at the unemployment rate percentages when we dealt with President Bush and President Clinton. Okay. I want to fix that real quick. But as you see in this first graph, gives us false information because here it has us thinking that um, Clinton had a bigger gap over the Bush years, other than well, over what Bush had in his years. But as you look at the second, excuse me, it tells us that the gap was a little bit closer than what we're led to believe. While doing this assignment, it allowed me to learn the behind-the-scenes reasons for trickery that reporters, politicians, companies, and advertisers sometimes use. I believe the goal is to influence your decisions or choices to work in their favor. If I were to inform you of the true effects of differences or lack of, then you just might make a choice that doesn't benefit the outcome that I would want. When you look at the unemployment rate graph, this one here, it seems like a big difference, but if you look at the actual numbers, it shows less of a gap than the graph shows. These numbers here actually show just 200% of a gap. When we changed the axis to start at 0, it showed more of the actual difference than we were led to believe by the first graph. By recreating the Katera graph, we were able to see each company's contribution and gain a clear picture of each company's sales influence. In the first graph, we were led to believe that Katera may have had a more solid stance because of its location on the graph. Let me make this a little bit smaller so maybe you can see everything. But because we dissected it, we were able to actually find out that the 13.7 that it represented, this is the Katera graph. If you can see it, circular here, but we took the circle out and dissected it, and it's 13.7 that it takes up. That's actually more than what they actually contributed. That it represented was inaccurate, therefore giving it its proper percentage in our pie chart of 4.5. Other ways that companies fool us as consumers is when the actual demographics isn't represented in the reports of those that were sampled. Another way is when the questionnaires are biased or have no actual basis or connection to the product or ask questions that the consumer wouldn't actually know the answer to. Interviewers also sometimes are not asking questions thoroughly or don't record the response given in its entirety, if at all. This project has opened my eyes to the way I will look at advertisements in the future, as well as how I'll make decisions about consumer products and look at companies and their advertisements. I think I'd need a lot more detail than I would have required in the past before I jump to hasty decisions from now on. For number 3, we did a Venn diagram dealing with people that had type 2 diabetes, obesity, and high blood pressure. And we also did it as percentages of the probability of them all having all 3 or just one. According to the information that we're given, there are 326.2 million people in population, and 63.2 of them are affected by obesity, high blood pressure, or type 2 diabetes. In order to convert our numbers for the Venn diagram, we had to work backwards in order to get our number to use for the rest of the chart. So we started at the bottom and worked our way up. We also had to divide by the population total to get our percentages. Our diagram shows that 3.1% of Americans are obese, while 8.5% have all 3. 16.1% are obese with high blood pressure, 0.9% have type 2 diabetes and high blood pressure, and 0.9% also have type 2 diabetes and obese. According to the state charts, in Arkansas alone, the population from a 2015 census is 2,978,204, whereas 35% are obese, 41.3% have high blood pressure, and 12.2% have type 2 diabetes. While looking at these same charts, it's quite obvious that people from the southern states are more likely to be affected by one or more of these traits, whereas it seems less likely for those that are in western states. When we get to number 4, we're looking at the heights of Army recruits in inches, as well as heights of random mall shoppers in inches. So we're doing a comparison. Here we have two different charts. For the recruits, the first graph tells me that all of them are probably males, because they're all around 6 feet and are around the same height with slight variation of a 4-inch difference between each of them. The shoppers are probably a mixture of both men and women, and they differ in as much as a possible 14-inch spread amongst them all. The tighter the data, which is shown by this graph, means the smaller the deviation. The wider the graph means more of a standard deviation. Just as the wider the spread, the bigger the whisker plots will be. The tighter the data, the smaller the whisker plots will be. Coefficient of variation also tells us because of the smaller the number, the smaller data or tighter plots we can expect to have. In these here, you see your whisker plots. Smaller data, smaller plot. Bigger, much more data, spread out, bigger plot. Here we have a study of sleep patterns of 217 Duke University scholars. Here you see our slope, and here is what my sleep pattern figures to be. When you increase the standard deviation, the slope got wider, but if you decrease the number, the slope got skinnier and became more of a hill. If you change the mean, then your whole slope changed positions. For the most part, 68% of the students get 4 to 8 hours of sleep consistently. For me, I normally get around 5.5 to 6 hours of sleep. And according to our chart, 34.1% of the students get about that much as well. So that tells me that we could all use a little more sleep. According to this chart, a little over 6% of the families make anywhere, and we're speaking about this chart here, they make anywhere from $15,000 to $20,000 yearly, while less than 1%, talking about this little piece right here, make anywhere from this little piece, make anywhere from $130,000 to $200,000 yearly. For our final one, we have an investment, a startup company. Sorry, I don't know what I did, but okay. I fixed it. Talking about a startup company that a guy did with flamethrowers. And his initial investment, which is represented by this blue star, was $12,000. Okay? Which that had him, he was upside down because he hadn't turned a profit yet. He was just, that was just what he used to get started. Now the bottom dollar, this is represented right here. This is where he sold 100 flamethrowers at this point. but he still hadn't. This is when he actually started seeing a turnaround in his sales. He was still in the negative, but he could see it turning around. His break-even point is represented by this gold star. This is when he actually did see profits on the positive side. And this happened actually around his 203rd sale. And his initial investment had doubled at 220 sales, and this is what this is right here. His 203rd sale is right here. He had to sell 258 flamethrowers in order to make $91,895. When he sold 257 items, he made $89,896. I don't know his troubles, but I do know from experience that if you don't have the ready capital, it's a continuous struggle. My husband has been running his own lawn service since 2005, and it's been a ride. You would think that after going through this with him, why am I trying to start another business? And this ends the my video for today. Thank you and have a good day.